KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.com.
Students, now in this video we are discussing cofactors. So now how these cofactors helps in activation or in catalyzing activities. So that is we will see. So before that one, previous video continuation, so we left one enzyme now, enzyme information. So in previous video we have learned up to 5 enzymes, isn't it? Means our knowledge point of view, enzymes are classified into 6 classes now. So 5 are there in one video and one and only we left. So that's why we are discussing even that also. So last one is ligases. This one is a part of classification and nomenclature of enzymes, so don't forget it. Okay, now ligases, enzymes catalyzing the so these kind of ligases, enzymes catalyzing the what, linking together, means here catalyzing or the involves in the linking of or the linking together of 2 compounds. Means here suppose if you would like to link or if you would like to join the 2 compounds together, means here what is the kind of enzyme you have to use? Ligase or simply ligase. Okay, the enzymes are definitely which catalyzes the linking or the formation or the joining of 2 compounds together. Okay, for example, enzymes which catalyze, so once you say my enzymes which catalyze joining of carbon to oxygen bonds or the joining of carbon to CS, and here the joining of, so here the joining of CN bonds or a PO bond and etc. means CO bond or the between the linking between the carbon and oxygen, carbon and sulfur, carbon and nitrogen and phosphate and oxygen. Likewise, so we can observe the joining of there are different types of compounds together. So means these are all different types of examples we can be taken. But here through voice, what is the point mainly we can understand? No, definitely ligase helps in linking or the joining of 2 compounds together. Okay, now let us enter into the actual concept today. Now cofactors. Now enzymes are composed of one or several polypeptide chains. Okay, suppose if you see enzymes are made up of one or several polypeptide chains. So this particular point also important and save pannikonga. However, there are a number of cases in which non-protein part constitutes cofactors. Means here there are even though enzymes are made up of polypeptide chains, means proteins, some kind of enzymes if you see there sometimes we will observe the involvement of non-protein part also. So means here if you observe the enzymes, 2 different types of enzymes are there. One is a simple one and one more is complex one. So now here if you take a simple enzymes, so that one, these simple enzymes are made up of only with proteins, and a complex one or a whole enzyme if you see, that one is made up of both the protein part as well as non-protein part. So now here what is the point here, one understanding means, so sometimes means maximum enzymes are made up of with the protein parts only, but sometimes along with the protein part there will be a non-protein part. So that particular non-protein part only we are considering as cofactors. non-protein part we are considering as cofactor, are bound to the enzyme to make the one particular or to make the enzyme catalytically active. Means here sometimes so one complex enzyme formation time, what is happening? No, first of all protein part and as well as a non-protein part both are required. My dear students, நல்லா சேவ் பண்ணிக்கோங்க. இப்போது enzymes, suppose classification of enzymes, if you take there two types of enzymes we can be divided. Okay, so thereby here what is the point here we can understand? So once I will give you the classification, so thereby you will understand clearly. Once you will understand clearly. Once you see here we have written enzymes classification or the types. Now enzymes, now our convenience to study, we divided it into simple and complex. Simple and complex. Now the simple one, simple enzyme, it is only made up of with proteins. Only proteins are involved in the formation of simple enzymes. And the second one, if you see there, no, it is a complex enzymes, or it is also known as a holo enzyme. Complex one or holo enzyme. Now this holo enzyme is nothing but functional unit of enzyme. Functional unit of enzyme. Now this holo enzyme, how it is a formation takes place? So that one, this particular holo enzyme is formed with the protein part and with the non-protein part. Means what is the point? Protein part and non-protein part both comes together and form holo enzyme. So thereby holo enzyme, if you observe, holo enzyme is made up of two compounds or the two constituents. One is a protein part known as apoenzyme and non-protein part known as cofactor. One more time you see protein part. Once you say along with me, holo enzyme can be divided into two parts. One is a protein part and one more is non-protein part. Protein part we are calling as apoenzyme and non-protein part we are calling as cofactors. Means if you see one particular holo enzyme, there definitely two parts are there. Can you tell what are the two parts? One is a protein part and one more is non-protein part. Okay, so protein part now we are calling as apoenzyme and non-protein part we are calling as cofactor. Okay, so now cofactors, again cofactors for our convenience to study. Now we are dividing into organic cofactors and metal ion cofactors. So this is a second case. Okay, now here you come back to the cofactors information. So now what is the information here we can discuss? Enzymes are composed of one or several polypeptide chains. So means here based on this point what we can understand, the enzymes are, so based on this first line we can understand it is a simple enzyme. Means kandipa made up of only with proteins. Point you understood now. However, once you see second line, however there are a number of cases in which non-protein part constitutes called cofactor, means are bound to the enzyme to make the enzyme catalytically active. Means here sometimes what is happening, non-protein part also required for making of an enzyme. So that particular non-protein part only we will be considering as cofactor. Means here, sir, ipo cofactor mattum irukana enzyme active ama sir, means no ma. First of all, protein part must be there, along with the protein part, non-protein part also must be there. Ipo protein part and non-protein part rendume combinedly forms the one important enzyme, one complex enzyme. So now protein part means apoenzyme we can take. And non-protein part now we will be considering as cofactor. Point I hope you understood now, right? Now in these instances, protein portion of the enzymes is known as apoenzyme. Even that point also I have written here, you can get now. So now here the protein portion or the protein part of the enzyme we will be considering as apoenzyme. Next one, three kinds of cofactors are there. Three kinds of cofactors. Are there. What are those? Three kinds of cofactors may be prosthetic group, coenzymes and metal ions. According to the textbook point of view, just simply they didn't give that much deeply, and you people are also not accepting a deep information. So that's why I'm even myself also giving superficially. Now the three kinds of factors we will observe. So here, what are the three kinds of factors means? Prosthetic group is there, coenzymes are there, and one more is metal ions also are there. Likewise, we will observe the three kinds of cofactors. Can you say along with me? Prosthetic group, coenzymes, and one more is metal ions. Okay, now prosthetic group point of view. Prosthetic group are organic compounds and are distinguished from one another from other cofactors in that they are tightly bound with the apoenzyme. Means here, if you see prosthetic group, if you see the prosthetic group, and these are all organic compounds. So prosthetic group definitely we will be considering under organic compounds, and here what is the main important point? So this prosthetic group of organic compounds are distinguished from the other cofactors, in that they are tightly bound with the apoenzyme. Means here the prosthetic group definitely how it will binds to the apoenzyme. Apoenzyme is nothing but what? Protein part only, no. So this prosthetic group will go and binds very tightly to the protein part known as apoenzyme. For example, if you see in peroxidase, the catalase, peroxidase and catalase. So which catalyze the breakdown of hydrogen peroxide into water and oxygen. So and heme is a prosthetic group, and it is a part of active site of the enzyme. So means, for example, if you see there peroxidase and catalase definitely which involves in the catalysis or reactions, and in catalysis reactions what they will do, sir, means break down the hydrogen peroxide H2O2 is there, no, hydrogen peroxide. So that will be converted into water plus oxygen, so with the help of peroxidase and catalase. Next one here, heme, if you see there, no, heme we will be considering as a prosthetic group. So means here even heme also it will be, or it will bind very tightly to the apoenzyme. Apoenzyme is nothing but protein part. Don't forget, we have to remember, at any cost we have to remember. Okay, next one. So thereby this particular heme will go, it is a prosthetic group, no. So thereby it is a part of the active site of the enzyme. So definitely, suppose if the enzyme is being active means definitely there is a involvement of cofactor. Now here there if you take the prosthetic group, no, even that particular prosthetic group also will go and binds to the enzyme very tightly, and we will observe the activation of enzymes. Now second one, coenzymes are also organic cofactors, but their association with the apoenzyme is only transient. Second one, now prosthetic enzymes are there, no. Now coenzymes. Now these coenzymes pathambodhu, and these these enzymes also are organic. Means here even prosthetic group also organic compounds. Likewise, even coenzymes also organic compounds, but their association with the coenzyme is transient. So loose association will be there. Loose association, transient association. So that carries a meaning loose association or like unstable. Okay, so and usually occurring during the course of catalysis. Means during the course of catalysis means when the particular enzyme is going to be involved in catalysis reactions, coenzyme that will go and binds to the apoenzyme loosely. Don't forget, prosthetic group, if you see there, no particular prosthetic group will go and binds to the apoenzyme very tightly. Suppose if you take coenzyme that binds to the apoenzyme, how? Loosely. Even these points only sometimes they will highlight in examinations. Okay, ma? Right. Try to save in your mind. Right. Now, further, more coenzymes serves as cofactors. Definitely, that's why here we will give you that information in a table. So now, further, more enzymes serve as cofactor in a number of different enzyme catalyzed reaction. So definitely, so this particular point we will understand in the table. Next one, the essential chemical compounds of remember now, next one, essential chemical compounds of many coenzymes or vitamins. So now here if you see there, essential chemical chemical compounds of many coenzymes means here if you take a coenzymes point of view, so under coenzymes we will take even vitamins also. So that's why here essential chemical compounds of many coenzymes or vitamins. This is important. For example, coenzyme. So here nicotinamide adenosine dinucleotide. One more time, can you say? Nicotinamide adenosine dinucleotide. So simply NAD. NAD is nothing but nicotinamide adenine dinucleotide. Okay, and one more is NADP. NADP, now can you guess? Nicotinamide adenine dinucleotide phosphate, NADP. So contain the vitamin niacin. Ipo parama coenzymes examples one is NAD and one more is NADP. Ipo NAD and NADP contain vitamin niacin. Okay, now here what are the main important points? Even sometimes suppose if they ask example, NAD and NADP both are comes under what? Suppose in options, no, if they give there are different types of options, so what we have to identify? NAD and NADP are coenzymes. So right now a number of enzymes. So before I start to explain this one, once this particular table I'll explain by one more time. So what is information? Enzymes. Enzymes are there. The enzymes, now our knowledge point of view, now we divided into two types. One is a simple enzyme and one more is complex enzyme. Now the simple enzyme, it is made up of only with proteins. Next one, second one, if you see there no complex enzyme, it is made up of with, once you come here, it is made up of with protein part and one more is non-protein part. If protein part is known as apoenzyme and non-protein part is known as cofactors. If complex enzyme we are calling by one more name, holoenzyme. Means here the holoenzyme is formed by two compounds or two parts. One is a protein part and one more is non-protein part. One is a protein part and one is a protein part and another one is non-protein part. Protein part we are calling as apoenzyme and non-protein part we are calling as cofactor. Again now you come down here, there cofactors. So here cofactor is there, no, non-protein part. Adi now we have started to discuss. Now cofactors are there. Now these cofactors, organic cofactors are there and second one is metal ion cofactors are there. Now organic cofactors point of view. Organic cofactors, now two types are there. One is coenzymes and one more is prosthetic group. Organic cofactors, two types we can be considered. So there one is coenzymes and one more is prosthetic group. Now coenzymes, so as we have seen before, coenzymes which are loosely bind. So which binds very loosely. So it binds very loosely with the apoenzyme, which bind very loosely with the apoenzyme. And whereas a prosthetic group, as we have seen before, this prosthetic group it binds very tightly to what? Very tightly bound with the apoenzyme. Don't forget, organic cofactors are there. That's why, did you remember one point? So this side we don't know coenzymes, organic compounds, and coenzymes as well as prosthetic group also, both are organic compound we see. That's why here we have written organic cofactors. For our convenience to study, we divided into two types. One is coenzymes and second one is prosthetic group. Now coenzymes are loosely bound with the apoenzyme. Apoenzyme is nothing but protein part. Prosthetic group tightly bound with the apoenzyme. Second one, if you see here, metal ion cofactors. Metal ion cofactors are also tightly bound with the apoenzyme. Metal ion cofactors. So now here, definitely sometimes so for the activation, so that is only here we will discuss here. For the enzymation activity or for the catalyzing of any enzyme, definitely sometimes there is the involvement of metals. So for example, Mg2 plus, Cu plus and Mn2 plus. Likewise, there are different types of. Okay, so there are different while taking NEET class, no? So what are the metal ions are there? What is the importance? Everything I will give you. So now it is enough. It is more than enough to you now. So now here the metal ion or metal ion cofactors, so which tightly bound with the apoenzyme. Okay, now go to the information. Now let us continue to get the information. Now a number of enzymes require metal ion for their activity. Point you understood now. Thereby we are understanding one point. Number of enzymes. So there are different types of, or there are different kinds of enzymes required metal ions for their activity. Means suppose if metal ions are not there, means enzymes will not be activated. Okay, and which form coordination bond with side chains at the active site and at the same time form one or more coordination bond with the substrate. Point understanding panikonga what we read now, no? So here what are the enzymes are getting off or getting of metal ions, so their further activity. So after that what is happening? Making bond. So means here some kind of a bonds formation takes place between the enzyme as well as metal ions. At the same time enzymes getting coordination bond even with the substrate also. Point you understood. இப்போ one metal ion இருக்கமா, அது metal ion போய் enzymes க்கு bind பண்ணும்போது, so coordination bonds formation takes place. Same kind of coordination bond enzyme will make with substrate also at the same time. Point you understood, no? Means there metal ions are there with the enzyme as well as substrate also is there with the enzyme. Okay, once the enzyme is activated with the metal ions, that particular same enzyme making bond with the even substrate. So that's why here we have written like this. Once you read and get the information, so what is that? Number of enzymes which require metal ions for their activity, which form coordination bond with the side chain at the active site and at the same time form one or more coordination bond with the substrate. We got the explanation now. Now for example, zinc. Zinc is a cofactor for the proteolytic enzyme carboxypeptidase. Means here definitely zinc Zn2 plus is required. So Zn2 plus, that is zinc is required for the activation of carboxypeptidase. Now here the carboxypeptidase enzyme is a proteolytic enzyme. For the activation of this carboxypeptidase or proteolytic enzyme, Zn2 plus is required. Why? Because here the Zn2 plus is acting as cofactor. Okay, next one, catalytic activity is lost. Catalytic activity is lost when the cofactor is removed. Easy only, no? Means suppose if the enzyme being very happy means or happily or it is working or it is involved in catabolic reactor catalytic reactions means definitely there is a involvement of cofactors or metal ion cofactors. Suppose here the metal ion cofactors not bound to the apo enzyme, how this particular enzyme will be free or happy? So that's why here what is the meaning? Suppose if the catalytic activity is lost, so when definitely when the cofactor is removed. Suppose if the cofactor is removed, so definitely catalytic activity of an enzyme is lost. Okay, means definitely which testifies that they play the crucial role in the catalytic activity of the enzyme. So thereby based on this one point we will understand very clearly. Suppose here the enzyme performing the catalytic reactions means definitely there is a need of cofactors or the metal ion cofactors. So suppose if there is no involvement of metal ion cofactors means even enzyme consists of a protein part or whatever it is cannot show the catalytic activity. Kandipa for the activation of the enzyme metal ion cofactors are required. For example, even one example also we seen Zn2 plus, if you see that particular Zn2 plus acts as cofactor and at the time for the activation of the carboxypeptidase enzyme Zn2 plus is required. Suppose if the Zn2 plus is not there, zinc not there, carboxypeptidase will not be activated. So that is information we can discuss. Even here enzymes classification, somewhat a classification of the enzymes we have discussed. Why? Because here what is a protein part and what is a non-protein part and what are the cofactors, what are the types of cofactors. So suppose this particular table, suppose if it is not there in our mind, this entire table, so till now what is the information we got, that one will not be entered into our mind. First of all, protein part means apoenzyme and non-protein part is cofactor. Next one, cofactors two types, organic and metal ion. Organic cofactors coenzymes and prosthetic group. Coenzymes loosely bound with the apoenzyme as well as a prosthetic group tightly bound with the apoenzyme. Likewise, this primary information first of all we must know, then only we can go with the concept. So actually my dear student, it is not there in our textbook. Okay, so for our understanding point of view I have given this one. Don't consider it as extra information and don't be in trouble. Okay, learn this first, so thereby you will understand this entire information, other than you cannot. So thereby watch these videos clearly. So till the getting of this information into your mind, later only try to go with the another concept. Thank you.